In this lesson, we're going to take a look at the volume of cylinders, spheres, and cones. We're going to just examine the volume of cylinders, the volume of cones, and the volume of spheres, and we're going to try to apply them to some problems. So the volume of a cylinder is the area of its circular base times height, which is the area of a circle is pi r squared times height, where r is the radius of the circle and h is the height of the cylinder. For all the problems in this lesson, we're going to leave our answers in terms of pi, because in some problems you may be told to leave it in terms of pi. You may be told pi is 22/7, or pi is 3.1, or pi is 3.14. So I'm just going to show you how to apply this formula, and then whatever pi is in your case, you can always simplify. So what is the volume of the cylinder below? So the volume of a cylinder is pi r squared h, which is pi, the radius is 14 centimeters squared, and the height is 25. So this is going to be pi times 196 times 25, which is going to give us 4900 pi cubic centimeters. Now we're told the height. What is the height of the cylinder if the volume is 2160 pi cubic centimeters? So let's start off with, what do we know about the volume? The volume is pi r squared h. So 2160 cubic centimeters, it's pi times 2160 is equal to pi times 12 squared times height, which is 2160 pi cubic centimeters is 144 pi square centimeters times height. So let's divide by 144 pi square centimeters. We divide this by 144 pi square centimeters, and we have 15 centimeters is the height of the cylinder. Now let's look at the volume of a sphere. You can look at a sphere as some form of a three-dimensional circle, like a ball, basketball, soccer ball, or tennis ball, something that looks like that. And so the volume is 4/3 pi r cubed, where r is the radius of the sphere. So let's look at this sphere, and we're going to try to find the volume of the sphere. So V is 4/3 pi r cubed, which is going to be equal to 4/3 pi times 9 cubed, which is 4/3 pi times 9 times 9 times 9. So we divide 3 by 3 and we divide 3 by 9, we get a 3. So this is going to be 12 times 81 times pi, which is 972 pi cubic feet. So the spherical ball below contains 4,500 pi cubic feet of helium gas. What is the diameter of the ball? So we go this way. Volume first, 4/3 pi r cubed. So this is 4500 pi is equal to 4/3 pi r cubed. Now we multiply both sides by 3/4. and that should get rid of the fraction. So if you multiply this by 3 over 4, you have 3,375 pi equal to pi r cubed. We can divide by pi to get rid of it. So 3375 is equal to r cubed. So let's see if we can simplify that. Let's use our factor trees, or you can use your calculators for this. So what we're going to do now is we're going to find the cubic root of both sides. So we have 3 and then we have 1125. We decompose 1125, we have 3 and 375. Then we have 3 and 125. We have 5 and 25, and then we have 5 and 5. So because we're looking for a cubic root, we're going to look for groups of 3. 1, 2, 3. Okay, 1, 2, 3. So this is going to be 3 times 5. So r is going to be equal to 15 feet. So the diameter is 2 times r, which is 30 feet. Now we're dealing with the volume of a cone. In this case, the volume of a cone is 1/3 the volume of a cylinder. So here we know that the volume of a cylinder is pi r squared h, and then so the volume of the cone is, just divide that by 3, where r is the radius of the circle and h is the height of the cone. What is the volume of the cone below? So the volume is 1/3 pi r squared h, which is 1/3 pi times r squared is 11 squared times h, which is 15. So let's simplify that. That's going to give us 5. So this is going to be pi times 121 times 5, which is 605 pi cubic centimeters. So the cone below is used to store ice balls. The balls have a diameter of 3 centimeters. How many balls will be needed to fill up the cone? So let's look at the volume of the cone. Volume of cone, 1/3 pi r squared h, which is going to give us 1/3 pi times 6 squared times 10, which is 36 pi times 10/3, which is 120 pi. And then the volume of the ball is 4/3 pi r cubed, which is 4/3 pi times 3 cubed, which is 4/3 pi times 27, which is equal to 36 pi. So 36 pi cubic centimeters and 120 pi cubic centimeters. So how many of the balls do we have in the cone? So we're going to divide volume of cone divided by volume of ball to find out how many balls will fit in the cone. 120 pi cm cube, or cubic centimeters, divided by 36 pi cubic centimeters. So if you put this in a calculator, you get 3.3 which is a non-terminating decimal, a repeating decimal. So we're going to end up with 3 of such balls in this cone.